7.6 goes over complex numbers. Complex numbers are something like I. I is the set of numbers indicated by the square root of -1. I squared is just -1. So if we look at these, we're going to be working in the form of a plus bi. So your real number will go first, then your complex number will always go second. That complex number is considered to be an imaginary number as well. So when we look at these, that real number will always go first. So like you see here, these different examples, you have -3 minus 5i. So your real number goes first, your complex number or your imaginary number goes second. It's with all of these cases. The first part that we're going to be focusing on today is finding the sums and differences of these complex number expressions. So you're going to follow your same rules that you would with simplifying these expressions if you had like terms such as 2x and 3x and combining those like terms. If we look at example 1a, we have 2 plus 3i plus 6 plus I. We're going to rewrite this without the parentheses first. So we just have the addition sign between the two, so we can get rid of those parentheses and just have 2 plus 3i plus 6 plus I. You're going to combine like terms next. So any of your real numbers, which are the 2 and the 6 in this case, would combine. This gives us 8. Now your complex numbers or your imaginary numbers combine. You have 3i and I, just like saying 1i. So 3 plus 1 is 4. Keep the I attached to it. So altogether, we just have 8 plus 4i. For example B, we have -2 plus 3i plus -2 minus 5i. For this one, again, we're just going to rewrite this without the parentheses since there is addition between the two sets of parentheses. So we have -2 plus 3i minus 2 minus 5i. Your real numbers are the -2's. You combine them, you get -4. Your complex numbers or imaginary numbers are the 3i and the -5i, which combine to give us -2i. So altogether, we just have -4 minus 2i. And again, if you realize with this question, as well as the one we did before this, it is in the form of a plus bi. So that complex number, that imaginary number, will always go last within your binomial. That's your answer. For example C, we have 3 plus 5i minus 1 plus 2i. So because there's a negative between these two sets of parentheses, we are first going to distribute that negative into the second set of parentheses and just rewrite this as 3 plus 5i minus 1 minus 2i. From here, you're going to do the same exact thing that you did for the two questions before this and just combine your like terms. For this, your 3 and your -1 are like terms. It gives us 2. 5i and -2i are like terms, which give us a positive 3i. So our solution for this one is just 2 plus 3i. For example D, we have -2 minus 3i minus 1 minus I. So again, we're going to distribute that negative in. Rewrite this as -2 minus 3i minus 1 plus I. So our like terms, we combine. We get -3 minus 2i. For your next part of your lesson, we are just going to be finding the product of these complex number terms or expressions. For example, 2a, we have 2i times 1 plus I. So we are going to distribute this 2i into the set of parentheses that we have there. So we're going to be doing 2i times 1 and 2i times I. 2i times 1 is just 2i. 2i times I is 2i squared. We said that in the very beginning of this lesson that I squared is equal to negative 1. So rewrite this as 2I plus 2 times negative 1. If we simplify this, it gives us 2I minus 2. Now, this is not written in the form that we need it. We need it in the form of A plus BI. So that negative 2 is going to go first. And then we just have that 2I that goes second. So we distributed in that 2I. We multiplied it by 1. We get 2I. We multiply by I. We get 2I squared. We said that I squared is equal to negative 1. So we just replace that I squared with negative 1 and multiply it by that 2. We get 2I minus 2. Put it into your standard form of A plus BI gives us negative 2 plus 2I for our solution. For example B, we have 2 plus 3I times 4 plus 5I. For this one, we are just going to FOIL. So 2 distributes into the second set of parentheses, and then that 3I distributes into the second set of parentheses. So 2 times 4 gives us 8. 2 times 5I is 10I. 3I times 4 is 12I. And 3I times 5I is 15I squared. We are going to combine our like terms. At the same time, we want to replace that I squared with a negative 1. So this gives us 8 plus 22I plus 15 times negative 1. From here, we're going to multiply the 15 times negative 1. It gives us 8 plus 22I minus 15. From here, your 8 and your 15 are like terms. So from here, you combine the 8 and the 15, you get negative 7 plus 22I. And again, we want this in A plus BI form. It is in that form, so we don't have to do anything else with this to rewrite it. That is your answer. For example C, we have 3 plus I times 3 minus I. Now this is a difference of squares, so we could just take the first term, which is 3, and square it, minus the second term, which is I, and square it. The 3 squared is 9. The I squared is negative 1. So this becomes 9 plus 1, which is 10. From here, we are going to be looking at multiplication or writing expressions in the form of A plus BI, where we have a term raised to a power, where that complex number is raised to a power. You are going to want to write this down. If you look at this, so for right now, just write this down. You have 0, you have 0.25, you have 0.5, and 0.75. With all of these, when you have your power that's on that I, you're going to divide that power by 4. Whatever your decimal part is for that is going to tell you what you're going to have as part of your answer. You'll either have 1I, negative 1, or negative I. So if we look at these, for example, 3a, you have 2I raised to the second power. This 2 gets raised to the second power. The I gets raised to the second power. This leaves us with 4I squared. You know off the top of your head that I squared is negative 1. So this is the same thing as saying 4 times negative 1. However, if you took that 2 and divided it by 4, it would give you a 0.5. Look at the little X or the little cross thing that I gave you, where your decimal part is 0.5. What is it equal to? It's equal to negative 1. So it's the same exact thing as saying 4 times negative 1, which is just negative 4. So this little table thing that I just drew for you with your 0, your 0.25, your 0.5, and your 0.75, 0 equaling 1, 0.25 equaling I, 0.5 equaling negative 1, and 0.75 equaling negative I is just an easier way, or like a cheat, in order for you to get to your final solution with these in a simpler way. For example, B here, we have negative 2i raised to the 4th power. So this is saying take the negative 2, raise it to the 4th power, take the I, raise it to the 4th power. That negative 2 to the 4th power, do your negative 2 times negative 2, which is positive 4. 4 times negative 2 is negative 8, times negative 2 is a positive 16. That I to the 4th power, if we divide the 4 by 4, we get 1.0. 0 is 1. So that's 16 times 1, which is just 16. For example, C, we have I to the power of 6. So for this one, we're going to divide that 6 by 4. 4 goes into 6 one time with 2 left over, so 2 over 4 would be 0.5. That 0.5 on our little table gives us negative 1. So negative 1 is our answer for this. For example, D, we have I to the 22nd power. So we're going to take that 22, divide it by 4. We get 5 with 2 left over, so that's 5.5. Again, we have that 0.5 and on our 0.75. On our little table here, that 0.5 is negative 1, so our answer for this one is just negative 1. And for example E, we have I to the power of 19. We're going to divide the 19 by 4. We get 4.75. That 0.75 is, this is 1 I, negative I, so that gives us negative I for our answer. So the next part, which is the complex numbers and their conjugates, you are working with simplifying these fractions or expressions and multiplying by the conjugate in order to cancel out that I squared or to cancel out something. Remember, the conjugate of a binomial is the same two terms but the different sign between the two terms. So if we look at example 4, it tells us to find the product of the given complex number and its conjugate. So we're going to take what they give us. If we look at example A, they give us 2 plus 3i. We're going to put parentheses around that and then multiply it by its conjugate. Its conjugate, you're going to keep the 2, you're going to keep the 3i, change the sign between them. So instead of it being addition, it's going to be subtraction, and multiply the 2. Now you could FOIL this, or you could use your rule for a binomial or a difference of squares. When you do the difference of squares, you're going to take the first term, which is 2, and square it, minus the second term, which is 3i, and square that. The 2 squared is 4. The 3i raised to the second power is 9i squared. If we simplify this, that I squared is negative 1, so that's 4 minus 9 times negative 1. The negative 9 times negative 1 is a positive 9, so 4 plus 9 gives us 13. For example B, we have 5 minus 4i. If we put parentheses around this and write its conjugate to be multiplied by it, we're going to keep the 5, we're going to keep the 4i, and we're just going to change the sign between them, which will be addition now. So from here, we have a difference of squares, so we're going to take 5, square that, minus the 4i, square that. The 5 squared is 25. The 4i raised to the second power is 16i squared. I squared is negative 1, so it's 25 minus 16 times negative 1, which is going to give us 25 plus 16, which is 41. For our next example, we're going to be finding the quotient and writing our answer in the form of a plus bi. By finding the quotient of these, we are going to use what we just did, take our denominator, find the conjugate of it, and multiply the top and the bottom by the conjugate of the denominator. For example A, we have 5 over 3 minus 4i. We're going to put parentheses around the 3 minus 4i and write its conjugate next to it, so 3 plus 4i. What we multiply by the denominator, we also multiply to the numerator. So we're going to bring that up top as well and multiply that 5 by the 3 plus 4i. We distribute the 5 in. We get 5 times 3, which is 15. 5 times 4i is 20i. And this is all over 3 minus 4i times 3 plus 4i. So we're going to do 3 squared minus 4i to the second power. We simplify this by squaring those two terms. So we have 15 plus 20i over 9 minus 16i squared. That I squared is negative 1. So we're going to turn this negative into a positive because a negative 16 times a negative 1 is a positive 16 and cancel out that I squared. So we're going to do 15 plus 20i all over 9 plus 16. 9 plus 16 is 25, so that's 15 plus 20i all over 25. Your 15, 20, and 25 are all divisible by 5. So we divide each of these by 5 and we get 3, 4, and 5. So this gives us a final answer of 3 plus 4i all over 5. For example B, we have 3 minus I over 2 plus I. So I'm going to put parentheses about my numerator and around my denominator. In my denominator, I have 2 plus I. My conjugate of that is 2 minus I. So we're going to multiply the top and the bottom by 2 minus I. We're going to FOIL for the top. So 3 times 2 gives us 6. 3 times negative I is negative 3I. Negative I times 2 is negative 2I. And negative I times negative I is a positive I squared. This is all over that 2 plus I times 2 minus I. So we're going to take the 2, square it, minus I squared. We simplify this by combining like terms in the numerator and turning that I squared into negative 1. So that's going to give us 6 minus 5I minus 1. In the denominator, we're going to square both of those terms to give us 4 minus I squared. That I squared is a negative 1. So a negative times a negative is a positive. This is giving us 6 minus 1, which is 5, minus 5i, all over 4 plus 1. That 4 plus 1 is 5, so 5 minus 5i over 5. We simplify. All those 5s are divisible by 5, so they become 1s. And we have 1 minus 1i, which is just I, all over 1. So that's just 1 minus I. For example, C, we have 3 plus 2i all over I. Now, when you do this, think about this as the same exact thing as 3 plus 2i all over something plus I. If you add something to that I that's not going to change its value, the only thing it would be able to be is 0 plus I. So if you multiply this by the conjugate of 0 plus I, that would be 0 minus I. And 0 minus I is the same thing as just negative I. So we're going to multiply the top and the bottom of this fraction by negative I. Distribute it in to the top. So 3 times negative I is negative 3I. 2I times negative I is negative 2I squared. This is all over I times negative I, which is negative I squared. From here, simplify with this. that I squared is negative 1. So we're saying negative 3 times I minus 2 times negative 1 over the opposite of negative 1. Those double negatives turn into positives. So we have negative 3I plus 2 all over 1, which is just negative 3I plus 2. If we look at the next part of our lesson, we're just simplifying these expressions and writing in the form of a plus bi, where a and b are real numbers. With these, you are going to have to simplify the radical before anything else. So when you simplify these radicals, you have to take into consideration the negative underneath. Remember, the square root of a negative, pull that I out. It's no longer no solution. So if you look at example A, we have 3 plus the square root of negative 9. The negative comes out as an I, so it's just 3 plus I square root 9. You know the square root of 9 is 3, so we're going to have 3 plus 3I. And whenever you do this, your real number will go in front of that imaginary number of I. So when you write this, whatever your radical simplifies as, the I comes after it. For example B, we have the square root of negative 12 plus the square root of negative 27. Again, those negatives have to come out, so we're going to pull them out by putting an I in front of the square root. So we're going to have I square root 12 plus I square root 27. The 12 is 4 times 3. 4 is 2 times 2. So that gives us 2I square root 3. The 27 is 3 times 9. 9 is 3 and 3. So that's 3 square root 3. So that's 3I square root 3. Now these two terms are like terms because they have the same radical attached to them. So treat I like it's a variable. If you had 2x plus 3x, it would give you 5x. So 2I plus 3I gives us 5I, and we keep the square root of 3 attached to it. So it's just 5I square root of 3. For example C, we have negative 1 minus the square root of negative 18 all over 3. For this negative 18 underneath the radical, pull that negative out by putting an I in front of it. So it becomes negative 1 minus I square root 18 all over 3. From here, that 18 is 3 times 6. 6 is 3 times 2. You have a pair of 3's, so that's negative 1 minus 3I square root 2 all over 3. You cannot simplify this one any further, so that's your answer for this question. For example D, we have the square root of 4 times the square root of negative 4 times the square root of negative 9. First thing to do with these, pull those negatives out, put i's in front of each. So we're going to have I square root 4 times I square root 9. The square root of 4 is 2, so that's 2I. The square root of 9 is 3, that's 3I. 2I times 3I gives us 6I squared. The I squared is negative 1, so 6 times negative 1 gives us negative 6. For example B, we're given 3x squared plus 2 is equal to 0. For this one, we're going to start by subtracting the 2 from each side. We have 3x squared is equal to negative 2. Then we divide each side by the 3. And we get x squared is equal to negative 2/3. From here, we're going to take the square root of both sides. So we have that I that comes out. And we have x is equal to plus or minus I square root 2 all over the square root of 3. You have to rationalize that denominator, so multiply the top and the bottom by the square root of 3, and this gives us our answer of plus or minus I square root 6 over 3.